Hi, welcome to my channel Engineering Math Support. One student want to learn higher mathematics, he must have the basic knowledge in mathematics. Many students they are memorizing the formulas. During the examination time they are unable to recall it. Because of that reason, they fail to solve the problem and score the marks. In this video, we are going to see about trigonometric basics. Here I have explained what is meant by trigonometric ratios, reciprocal ratios, trigonometric identities, and based on trigonometric functions of sum or difference of angles, we are going to derive 16 formulas here. In between, I have given some hint to recall the formulas. Just listen carefully. Let's move on to the video. Trigonometry. Trigonometry, the word derived from the Greek words trignon and metron. Trignon means triangle and metron means measure. By seeing these two words itself, we can guess what we are going to do in trigonometry. Yes, we'll see the basic definition now. Trigonometric is a branch of mathematics, deals with the relationship between side lengths and angles of triangles. Now we are going to see about trigonometric ratios. To define these trigonometric ratios, we have to consider a right angle triangle. Right angle triangle means nothing but a triangle consists of 90 degree. Now, using this, we are going to define the terms 90 degree angle. If you are consider opposite side to that 90 degree angle is called hypotenuse. If you are considering the theta here, opposite to the theta is called opposite side. Below to that theta, the side is called adjacent side. So using this, we are going to define the ratios. Sin theta is nothing but opposite side divided by hypotenuse. To remember this, we can define this as SOH. So we can use this as a shortcut to remember this. S means sine, O means opposite side, H means hypotenuse. Now we are going to define cos theta. Cos theta equal to adjacent side by hypotenuse. To remember this, we are going to define like this: CAH, Ka. We can remember like this: C means cos, A means adjacent, H means hypotenuse. Similarly, we are going to define tan theta. The tan theta is defined as opposite side by adjacent side. We can also write the tan theta as sin theta by cos theta. To remember this, we can write the term as TOA, TOA. T means tan, O means opposite side, A means adjacent side. This is the way we can define the trigonometric ratio and we can remember it. Reciprocal ratios. Reciprocal of sin theta is cosecant theta, that can be expressed as cosecant theta equal to 1 by sin theta. From this we can find sin theta equal to 1 by cosecant theta. Reciprocal of cos theta is secant theta, that is secant theta equal to 1 by cos theta. From this we can write cos theta equal to 1 by secant theta. Reciprocal of tan theta is cot theta, that can be expressed as cot theta equal to 1 by tan theta. From this we can write tan theta equal to 1 by cot theta. We know that tan theta equal to sin theta by cos theta. applying here, we will get our cot theta as cos theta by sin theta. So we must have the knowledge of trigonometric ratios as well as reciprocal ratios to remember the formulas as well as derive the formulas. Basic trigonometric identities. The identities are derived from rectangle triangle using Pythagoras theorem. Some of them are called Pythagoras theorem also. There are three identities. I am going to derive the identities from the first one. The first identity is sin square theta plus cos square theta equal to 1. We have to take this as a base one to remember or derive the other two identities. To derive the second identity, I am going to divide the equation 1 by cos square theta. If you divide that equation 1 by cos square theta, we get sin square theta by cos square theta plus cos square theta by cos square theta equal to right hand side is 1 by cos square theta. Here these two are same, so I have cancelled it and we get 1 here, and this term is nothing but tan square theta from the trigonometric ratio, and this is nothing but our secant square theta. This term can be expressed as tan square theta, and this one is 1, and your right hand side is secant square theta. So therefore our second identity is tan square theta plus 1 equal to secant square theta. The same way I am going to derive the third identity. For that, I am going to divide the equation 1 by sin square theta. If you divide the equation 1 by sin square theta, we get sin square theta by sin square theta plus cos square theta by sin square theta equal to your right hand side is 1 by sin square theta. Here these two are same, so I have cancelled, and we know that cos square theta by sin square theta is cot square theta. Then your right hand side is 1 by sin square is nothing but cosecant square theta. These two are cancelled, so 1, and cos square by sin square is cot square theta, and 1 by sin square is nothing but cosecant square theta. So therefore your another identity is 1 plus cot square theta equal to cosecant square theta. So there are three identities. The first one, sin square plus cos square theta equal to 1. The second one is tan square theta plus 1 equal to secant square theta. And the third one is 1 plus cot square theta equal to cosecant square theta. If you can able to remember, you can remember. Otherwise, from the first one, we can easily derive the other two. The next concept is trigonometric functions of sum or difference of two angles. Here we are going to see four formulas. The first one, sin of a plus b equal to sin a cos b plus cos a sin b. How we can remember this formula? The trick is sin will have same symbol. Here plus, here also plus. If the symbol is same, the trigonometric is different. This you should keep in your mind to remember the sin formula. Using the trick, we are going to write the next formula, that is sin of a minus b equal to sin a cos b minus cos a sin b. See that sin means same symbol. Here minus, here also minus. Then the trigonometric is different, sin a cos b. And also we should remember that once the formula starts from sin, here the term is also start from sin only. This way we can remember these two formulas. The another two formulas are cos of a plus b equal to cos a cos b minus sin a sin b. How we can remember this formula? If you are having cos, you should remember different symbols. Here plus, here we will have minus. If the symbols are different, the trigonometry function is same. See that? Cos A, cos B. Here sin A, sin B. So you have to keep that in your mind. And based on this, we are going to define the next formula. Cos of A minus B equal to cos A, cos B plus sin A, sin B. See that here minus, here plus, here we should remember same trigonometric functions, cos A, cos B, here sin A, sin B. This is the way we can remember the formula. And if you observe here, the cos formula starts with cos only first. Using these four formulas, we are going to derive the following formulas. I'm going to take first two formulas, that is sin of a plus b equal to sin a cos b plus cos a sin b. Sin of a minus b equal to sin a cos b minus cos a sin b. Using this, we are going to derive the following two formulas. That is sin a plus b into sin a minus b equal to sin square a minus sin square b. That is also equal to cos square b minus cos square a. To derive this, if you observe the left hand side term, it is in the form of multiplication. So therefore, we are going to multiply the equation 1 and equation 2. Sin of a plus b into sin of a minus b equal to sin a cos b plus cos a sin b into sin a cos b minus cos a sin b. If you observe this, this is nothing but a, it is nothing but b, it is also a, and it is also b. This look like a plus b, and it is look like a minus b. Therefore, a plus b into a minus b equal to a square minus b square. Using this, I'm going to write the right hand side term as sin a cos b the whole square minus cos a sin b the whole square. From this, we can write sin square a into cos square b minus cos square a into sin square b. From this, we will have two options. Either we can convert this cos into sin form or sin into cos form by using the first identity, that is sin square theta plus cos square theta equal to 1. From this, I'm going to convert cos square in the form of sin square now. So therefore, cos square can be replaced by 1 minus sin square theta. Sin square a, as it is I have written, and this cos square b can be written as 1 minus sin square b minus this cos square a can be written as 1 minus sin square a into here sin square b. In the next step, I'm going to multiply the terms. Here sin square a into 1, you will get sin square a, and you will get sin square a into sin square b, you will get minus sin square a into sin square b, minus 1 into sin square b is minus sin square b, minus of minus plus, you will get sin square a into sin square b. If you observe, these two terms are same, so I have cancelled and I got the term sin square a minus sin square b. So therefore, the first formula as sin of a plus b into sin of a minus b equal to sin square a minus sin square b. The same way we can derive the another one by replacing this sine by cos form. That is sine square theta equal to 1 minus cos square theta. If sine square can be written as 1 minus cos square A into, I can return the term cos square B as it is, minus cos square A into this sine square B can be written as 1 minus cos square B. So then I'm going to multiply the term 1 into cos square B is cos square B and minus cos square A into cos square B, minus cos square A into 1 is cos square A and minus cos square A into minus cos square B is plus cos square A into cos square B. If you observe, these two terms are same, cos square A, cos square B. These two are same, so I have cancelled it. Then we will get the another formula cos square B minus cos square A. Therefore, sine of A plus B into sine of A minus B is also equal to cos square B minus cos square A. I'm going to consider the same formula, sine of A plus B equal to sine A cos B plus cos A sine B. Sine of A minus B equal to sine A cos B minus cos A sine B. Using this again, we are going to derive one more formula, that is sine of A plus B plus sine of A minus B equal to 2 into sine A cos B. If you observe this left hand side, it is in the form of addition. Previous problem, previous formula, it is in the form of multiplication. So now it is in the form of addition. We are going to add the two equations, that is sine of A plus B equal to sine A cos B plus cos A sine B plus sine of A minus B equal to sine A cos B minus cos A sine B. Now we are going to add these two equations. If you add, these two are same terms with opposite signs, so these two are getting cancelled, and these two are same term, so we can add it. So therefore, you are getting your left hand side as sine of A plus B plus sine of A minus B equal to 2 into sine A cos B. So the formula is sine of A plus B plus sine of A minus B equal to 2 into sine A cos B. Again, I am going to consider the same two formulas and I am going to derive one more formula, that is sine of A plus B minus sine of A minus B equal to 2 into cos A sine B. If you observe the left hand side, it is in the form of subtraction. So I am going to subtract equation 2 from 1. That is 1 minus 2 implies sine of A plus B equal to sine A cos B plus cos A sine B minus sine of A minus B equal to sine A cos B minus cos A sine B. Here, when we are subtracting the term, we have to change the signs. So therefore, I'm going to change the signs as plus into minus, minus, minus of minus, plus. Now I'm going to add the terms. Here, if you add, these two are opposite symbols, so I have cancelled it. And these two are same, and I'm going to add it. So therefore, sine of A plus B minus sine of A minus B equal to 2 into cos A sine B. So we got the another formula, sine of A plus B minus sine of A minus B equal to 2 into cos A sine B. We are going to see about the formula based on multiple angles. For that, I am going to consider sine of A plus B equal to sine A cos B plus cos A sine B. That is first formula I am going to take to derive this. The formula is sine of 2a equal to 2 into sine a cos a. To derive this formula, if you observe your left hand side, this is in the form of 2a. So therefore, I am going to replace b equal to a in equation 1 to get this format. So put b equal to a in equation 1. Then the equation 1 implies sine of a plus a equal to sine a cos a plus cos a sine a. Where and all b is there, we are replaced by a. So if you observe now, these two are same terms. So we add the terms. So therefore your LHS is sine 2a equal to your RHS is 2 into sine a cos a. So therefore our formula is sine 2a equal to 2 into sine a cos a. Next, I am going to use this sine 2a formula to derive the next formula sine 2a in the form of tan. For this, I am going to take the sine 2a equal to 2 sine a cos a formula as a star equation, and I am going to get tan form in this. How we can get the tan form? To get the tan form in your right hand side, we have to multiply and divide by equation star by cos a. If you do like that, your right hand side is sine 2a equal to 2 sine a cos a into cos a by cos a. So now to get the tan form, I will combine this sine by cos and I'm going to multiply this cos into cos. The next step is your right hand side 2 into sine a by cos a. Cos into cos will get cos square a. From this we can conclude your right hand side equal to 2 into tan a. This sine a by cos a is tan a, and we know that by reciprocal ratios cos square a can be written as 1 by secant square a. And also we know that what is meant by secant square a by the identity 2. So that I have replaced here. 2 tan a into 1 divided by secant square a can be written as 1 plus tan square a by reciprocal ratio. Therefore, our formula is sine 2a equal to 2 tan a divided by 1 plus tan square a. In the multiple angle formula, I have not discussed sine 3a. Later we will discuss it. We will do a recall now. We have taken sine of a plus b formula as well as sine of a minus b formula. Using this above formulas, we have derived sine of a plus b into sine of a minus b equal to sine square a minus sine square b. Sine of a plus b into sine of a minus b equal to cos square b minus cos square a. Sine of a plus b plus sine of a minus b equal to 2 sine a cos b. Sine of a plus b minus sine of a minus b equal to 2 cos a sine b. Sine 2a equal to 2 sine a cos a. Now sine 2a in the form of tan, we are derived as sine 2a equal to 2 tan a divided by 1 plus tan square a. If you observe, all the derivations are done by using only these two formulas. Now I am going to consider the third formula and fourth formula to derive the following formulas. That is cos of a plus b equal to cos a cos b minus sin a sin b. Cos of a minus b equal to cos a cos b plus sin a sin b. Same as the sine formula, what all the process we are done, same we are going to do it here also to derive the formulas. The first formula is cos of a plus b into cos of a minus b equal to cos square A minus sin square B. If you observe your left hand side, it is in the form of multiplication. So I am going to multiply the third equation and fourth equation. So it gives cos of A plus B into cos of A minus B equal to cos A cos B minus sin A sin B into cos A cos B plus sin A sin B. If you observe, this is look like A and these two look like what B. Here A minus B form, it is A plus B form. So if you apply the formula A plus B into A minus B equal to A square minus B square. Therefore, your right hand side becomes cos A cos B the whole square minus sin A sin B the whole square. Now, we can apply the square inside the terms. We'll get cos square A into cos square B minus sin square A into sin square B. We know that the first trigonometric identity sin square theta plus cos square theta equal to 1. From this, we are going to do the changes now. Since sin square can be written as 1 minus cos square form and cos square can be written as 1 minus sin square form. I'm going to replace the term as cos square A into this cos square B can be written as 1 minus sin square B. And this sin square A can be written as 1 minus cos square A. The remaining term sin square B written as it is here. Now we are going to multiply cos square A minus cos square A into sin square B minus of plus minus sin square B into 1 is sin square B minus of minus plus cos square A into sin square B. If you observe these terms, these two are same, we are cancelled and we got the remaining term as cos square A minus sin square B. Therefore, our formula is cos of A plus B into cos of A minus B equal to cos square A minus sin square B. I'm going to consider equation 3 and equation 4 to derive the next formula. The next formula is cos of A plus B into cos of A minus B equal to cos square B minus sin square A. If you observe the left hand side, it is in the form of multiplication. So I am multiplying that equation 3 and 4. This implies cos A plus B cos A minus B equal to cos A cos B minus sin A sin B into cos A cos B plus sin A sin B. Same as the previous case, it is look like A and it's look like B. Again, we are going to apply the same formula A plus B, A minus B. Since A plus B into A minus B equal to A square minus B square, we can write the right hand side term as cos A cos B the whole square minus sin A sin B the whole square. From this we can write the next step as cos square A into cos square B minus sin square A into sin square B. Again we are going to use the same trigonometric identity sin square theta plus cos square theta equal to 1. From this we are going to replace the cos square as 1 minus sin square theta and the sin square as 1 minus cos square theta. So the next step is cos square A can be replaced as 1 minus sin square A into cos square B minus sin square A into the sin square B can be replaced by 1 minus cos square B. If you multiply the term 1 into cos square B is cos square B minus sin square A into cos square B. Here plus into minus minus sin square A into 1 is sin square A minus of minus plus sin square A into cos square B. These two are same terms. I have cancelled. The next step is cos square B minus sin square A. Therefore, the formula is cos of A plus B into cos of A minus B equal to cos square B minus sin square A. Using the same two formulas, we are going to derive one more formula. Cos of A plus B plus cos of A minus B equal to 2 times of cos A cos B. If you observe your left hand side, it is in the form of addition. So therefore, I am going to add equation 3 and 4. The addition gives cos of A plus B equal to cos A cos B minus sin A sin B plus cos of A minus B equal to cos A cos B plus sin A sin B. If we add these two terms, if these two are looks like same, I have cancelled, and your left hand side is cos of A plus B plus cos of A minus B equal to your right hand side. These two are same terms, so we can write twice. We can add and write it as 2 cos A cos B. Therefore, our formula is cos of A plus B plus cos of A minus B equal to 2 times of cos A cos B. In the same way, using the two formulas, we are going to derive the next one. That is cos of A minus B minus cos of A plus B equal to 2 times of sin A sin B. If you observe your left hand side, it is in the form of subtraction. So I am going to subtract equation 3 from equation 4. 4 minus 3 implies cos of A minus B equal to cos A cos B plus sin A sin B. We are going to subtract cos of A plus B equal to cos A cos B minus sin A sin B. If you subtract, we have to change the symbol. So plus into minus minus. Here minus of minus will produce you plus. These two, it's look like same. We are cancelled, and these two are same terms. We are written 2 times of. So therefore, your LHS is cos of A minus B minus cos of A plus B equal to your right hand side 2 times of sin A sin B. Formula cos of A minus B minus cos of A plus B equal to 2 times of sin A sin B. Using the third formula, that is cos of A plus B equal to cos A cos B minus sin A sin B, we are going to derive the multiple angle formulas. That is cos 2A equal to cos square A minus sin square A. If you observe your left hand side, here it is 2A. So to get the 2A, we are going to replace B equal to A in equation 3. If you put B equal to A in equation 3, the equation 3 becomes cos of A plus A equal to cos A cos A minus sin A sin A. Where and all B is there, replace it by A. Now if you observe this term of your right hand side, here it is cos into cos, you will get cos square. Sin into sin, we'll get sin square. Therefore, our formula is cos 2A equal to cos square A minus sin square A. Now I am going to use this cos 2A formula to derive the another formula. Cos 2A equal to cos square A minus sin square A. I have considered it as equation star. The next formula is cos 2A equal to 2 into cos square A minus 1. If you observe your right hand side, it is in the form of cos. So therefore, using the first identity sin square theta plus cos square theta equal to 1, I'm going to replace the sin square term in the star equation in the form of cos. That is sin square A equal to 1 minus cos square A. We are going to substitute in equation star. If you substitute like that, we will get cos 2A equal to cos square A minus 1 minus cos square A. The next step, cos square A minus of plus minus 1 minus of minus plus cos square A. If you observe, these two terms are same, so we can add and write 2 times of cos square A minus 1. So therefore, our formula is cos 2A equal to 2 times of cos square A minus 1. This formula we are going to rearrange to get another formula. We can write cos 2A plus 1 equal to 2 cos square A. By taking this minus 1 to your left hand side, we got the term. From this we can conclude cos square A equal to 1 plus cos 2A by 2 by cross multiplying this 2 to your left hand side. Using the same formula, cos 2A equal to cos square A minus sin square A, we are going to get the next formula. Cos 2A equal to 1 minus 2 sin square A. If you observe your right hand side, it is in the form of sin. So therefore, using the identity sin square theta plus cos square theta equal to 1, I'm going to replace cos square in equation star in the form of sin square. Substitute cos square A equal to 1 minus sin square A in the equation star. The star equation implies cos 2A equal to, the cos square is replaced as 1 minus sin square A minus sin square A. This can be written as 1 minus sin square A minus sin square A. These two terms are same, so we can add and write cos 2A equal to 1 minus 2 sin square A. We can rewrite the term as this goes to your left side, and we can take this cos 2A to your right side, and we get the term as 2 sin square A equal to 1 minus cos 2A. From this, we can conclude sin square A equal to 1 minus cos 2A by 2 by cross multiplying this 2 here. Again, I'm going to use the cos 2A equal to cos square A minus sin square A formula to derive the cos 2A in the form of tan. Cos 2A equal to 1 minus tan square A by 1 plus tan square A. To derive this formula, if you observe your right hand side, it is in the form of tan. So we know that sin theta by cos theta equal to tan. So to get the tan form, we are going to take cos square A from the equation star. If you take cos square A from the equation star, the equation star becomes cos 2A equal to cos square A into 1 minus sin square A by cos square A. We know that cos theta equal to 1 by secant theta by reciprocal ratio. Sin theta by cos theta equal to tan. Applying this, we can write this step as cos square can be written as 1 by secant square, and this 1 we are written as it is, and this sin square by cos square can be written as tan square. And also we know that by identity 2, the secant square can be written as 1 plus tan square format. So therefore, here we are substituted the second identity 1 plus tan square A. Finally, we get cos 2A equal to 1 minus tan square A divided by 1 plus tan square A. Just we are going to see now, so what we have done by using these two formulas. Using these two formulas, we have the following formulas. That is, first we are derived cos of A plus B into cos of A minus B equal to cos square A minus sin square B. Second formula, cos of A plus B into cos of A minus B equal to cos square B minus sin square A. Third formula, cos of A plus B plus cos of A minus B equal to 2 times of cos A cos B. Cos of A minus B minus cos of A plus B equal to 2 times of sin A sin B. Cos 2A equal to cos square A minus sin square A. Another formula is cos 2A equal to 2 into cos square A minus 1. Using this, we derived cos square A equal to 1 plus cos 2A by 2. another formula in the form of cos 2a, that is cos 2a equal to 1 minus 2 sine square a. Using this, we are derived sine square a equal to 1 minus cos 2a by 2. Cos 2a equal to 1 minus tan square a divided by 1 plus tan square a. Using this sine of a plus b, sine of a minus b, and cos of a plus b, cos of a minus b, we derived nearly 16 formulas. Now we will see about the multiple angle formula of sine, that is sine 3a. Sine 3a equal to 3 sine a minus 4 sine cube a. So this also can be derived from the sine of a plus b formula by replacing b equal to 2a, and if you apply the formulas we can get this one. So instead of doing that, I can easily say a method to remember it. First, we can take this 3 in front of the sine and we will get the first term 3 sine a. 3 after 4, so we have to write 3 after 4 here. Then this 3 goes to the power of sine, that is sine cube a. So this is the way you should remember the sine formula. 3 goes in front of the term and we can write the first term as 3 sine a minus 3 after 4 we should remember. Then the 3 goes to the power of sine, that is sine cube a. So therefore the formula for sine 3a is 3 sine a minus 4 sine cube a. In the same way we are going to remember cos 3a. Cos 3a equal to 4 cos cube a minus 3 cos a. Just if you observe these two, we can easily remember. So here we can write this as a first term for cos, that is 4 cos cube a minus 3 cos a we have written as a cos formula. So therefore the cos 3a formula can be remembered by the sin 3a formula, 4 cos cube a minus 3 cos a. I hope through this video you learned some formulas and you learn how to memorize the formulas. If any doubt, kindly put it in comment box. Subscribe and press bell icon for further updates. Thank you. See you in the next video.